So we'll start recording this. Okay. So again, the basic idea would be a print. You print either strings or numbers or a variable. So if I have a variable, numbers here, okay. So again, inside of quotes, I can say that SEP by default looks like that. Double, we'll make it single. And I can change that. So that's the default behavior. That's all inside of print. Okay, I'll run this. Make sure I've got that right. Oh no, oh, it can't be inside. There has to be a comma, that's what it is. So again, that's the normal spacing, but inside of here, you can put more spacing if you want, which is going to give you that. Okay, you could do no spacing. Just run it together. Okay, which is not what you want probably. Or you could put anything, put letters, dashes, whatever makes you happy. Okay, so that's what happens between these. Okay. Then there's also the end. Again, by default, the end is going to be equal to the new line character. Okay, so that means if I have multiple print statements, this is the default behavior, so it automatically is going to print them on a new line. Okay, if I change that to nothing, then it's going to, just for the first one, the only one I changed. Okay, so now after I print this X, this number, the 6, 7, notice that the next line comes right up on it with nothing. Okay, I could also make that a tab. I could make it, I mean, you could make it letters. You wouldn't, it would be dumb, but you could. Okay, so again, it prints that, then it prints this one. Okay. Also remember with the print, we've got the format. So I can do a print. The format goes just along the line there. The function takes what you're printing, X in this case, and then you can put in number of spaces, minimum number of spaces if you want. You can put in a comma, which has to be in order. You can put in like how many decimal places, so a 0.2, then F for float. So if you do that, that will print the number in this format. Oh, I didn't change that. I'm like, why is it doing that? There are questions along the way. Ask. It's going to give us this. Okay. Remember, this is a string literal. A string would be something like, let's say, that would be a string variable. Okay. Comments just have the octathorpe or the hashtag, whatever you want to call it, in front of them. Your programs on the exam, like for the homework, should have hashtags. Okay. Or should have comments. Sorry. Okay. Variables, remember in Python, it's very loose about variables. The variables can be whatever you want them to be at whatever time. Okay. If you solve with the factorial program, one of the good things is that we're not bound by any kind of number of digits on our number. So we need to save as a computer memory. Okay, it's not a good idea to switch variables back and forth. Okay, but you certainly can do that. Remember also that we have, if you need it, the type function. I want to go below the screen. So let's say X is equal to 1223.3. I can then say the type of X, and it will return that it's a float. Okay. So the types we've used, we have floats, we have integers or ints, we have strings, we have bools or booleans. I think that's it so far. Oh, and no, that's it. Yeah, probably that. So, okay. Remember, a variable is not like it is in math, it's not an unknown. A variable is a label to some place in memory. Okay. We use the equal sign as the assignment operator for variables. Variables have naming rules, which are on page 43. Can't use keywords, can't start with numbers, those kinds of things. Let's see. Reading input from the keyboard. You've been doing that a lot, so that should be familiar to us if you work through the homework. It's with the input function. The input function takes a parameter as a prompt and it returns a string. Okay. You can't do fancy print kinds of things inside of your prompt. You've got to just put a pretty simple string. Okay. It returns it as a string. We can convert it with either the int or the float functions. Okay. Again, we've seen a lot of that. If you have questions, you can ask. Performing calculations, we have the plus, minus, star for multiplication, slash for regular division, 2 slashes for integer division. Remember, the difference is the integer division returns an integer always. Okay, so if you say 6 divided by something else, 6 divided by 5, okay, it would return a 1. Not any fraction portion. That kind of plays with the remainder or the modulo, which is the percent sign, which returns what the remainder is. Okay, we use that extensively on the prime number program we did in lab yesterday. Okay, I have released a video of my solution to that prime number program. So if that was confusing, that was a short program that was pretty dense. So there is a video out there. I encourage you to take a look at that. You can also ask questions now if you want. Okay. Remember the operator precedence, okay, starts with parentheses are always the highest precedence, and it goes to exponentiation, then multiplication, division, then addition, subtraction. All things being equal, it goes left to right, just like math. Good when it does things like that. Because it doesn't always, okay. Remember the exponents, star, star. And then make sure that you're familiar with how you can convert a formula on paper into one in the computer. Okay. That's about it. T-Wait talks about the enhanced stuff with print we just did. 2 non-named constants. Remember that if you have a number like any number that's going to be constant throughout your program, sales tax, interest rate, any of those things, you want to make it a named constant. Okay, named constant will be all uppercase letters. It's the only time we use all uppercase letters. Okay. Turtles are not on the test, so you don't have to worry about it. Turtle free. Some people are so happy, some are sad.
I mean, I just did the math yesterday. Then again, they also don't really work on.
They don't, that's correct.
Oh, will the tests all be on the computer or?
Yes. Well, it's all on the computer. Yeah, the first part, you'll do it in Word or something.
Okay.
Or yeah, it may be on paper. That may be on paper. Yeah, the first part probably will be on paper. And then you'll go and do programming, however you do programming. Bring a laptop if you want, bring whatever you want, okay? So chapter 3 is about decision structures and Boolean logic. So remember that is the if statement. If some condition, x of x equal to 5, I can say if x is less than 10, for example. And then this is what happens if the condition is true. Do it in the Python way. Okay. Where I'm at now happens no matter what. When you're out, so the indentation tells us. So when I'm back to the left margin, it doesn't matter if X is true or not. Okay. So this always executes. We can also have an else. And this is going to execute only if it's false. This still always executes. Okay. Again, the indentation is important. Okay. We can in addition, have as many as we want elifs that have their own set of conditional statements. Okay. And then again, this is if that elif is true. Okay. So you can build as many of those as you want. Remember when we compare strings, strings are weird. Strings are based on their ASCII values. Okay, so it does more or less, you can do it alphabetically, but remember that capital letters and small letters don't play well. I mean, all of the capital letters have smaller numbers than all of the small letters. Okay. We can do nested decisions. Okay, so we can say something like we have x equal 5, y is equal to 10. For example, we could say, start off here, say if x is greater than 10, and here have if y are less than 10 is y is less than 10. Then do something like that. Okay. Now, if you have a structure that requires indentation, you have to have something there, even if it's a comma. Okay. So we also have on this, we can use the operators and or. Okay, so I could, if it, I mean, instead of a nest, it depends on whether I want to capture those individual cases. I could say something like if x is greater than 10 and y is less than 100. Okay, then this would happen only if both of those are true for and. For the or, only one of them has to be true. A not just reverses the value of one of the others. Okay. We can also do Boolean variables. I could say something like big Y is equal to, I can either say false or true if I want directly, or I could put in a relational operator here, Y greater than 100. Then I could just say here, if big Y print big then else that's small, whatever you want to do. Okay, so there's our if or else with the Boolean variables. Okay, and again, total graphics we don't care about for detail. Okay, questions asked as I go. Repetition structures. Okay, remember that one of the big powers of the computer is ability to do things over and over and over and over and over without tiring. Okay, so we do that repetition with a couple of different structures. We have the condition controlled loops and we have the count controlled loops. The condition controlled loops go on until some condition is true, or is no longer true, depending on how you structure it. The count controlled loops goes for some determined, you know how many times it's going to go. Okay. So remember, for if you're going to only remember one loop, the while loop does everything. Okay. So for a condition controlled loop, I can set my initial condition and say while done. And then here I could print something that doesn't matter. Going. I can then have done is equal to input. Continue. No. Actually, I see I've got an issue there, but I didn't. A couple of issues. Let's not say that done. Let's say continue. But that makes it positive, not negative. And let's just say we'll make it a yes. So then we can say while continue yes. Or I can go ahead and put a continue. I need equality is 2 equal signs, so don't forget that. A big Y, big Print still going, do you want to continue? Yes, no. Change my variable name. Continue. Okay. That's going to keep going as long as the condition is true. They've entered a Y of a small or large variety. Okay. That's a condition control loop. Remember, a count control loop is when you know how many times you're going to do it. If you want to print out the numbers from 1 to 10, okay, you could set your initial value here or something like n is equal to 1. And then you can have your while be while n is less than or equal to 10. Then we can just print n. But here, remember, you always have to be moving toward the end. I can just set n being equal to n plus 1, or say n plus equal 1. Okay. That works as well. That's a count control loop. But remember, for a count control loop, I can do things easy. Okay, so we have two ways. We kind of ignored the first way because it can be kind of cumbersome. But sometimes it comes in handy. So I could say for n, and then specifically type a range. We've got to quit doing that once we got the range command. But I can type in this list of numbers, and that works. Okay, then I can print the n. That's perfectly okay, legit. But what we do more often, it's more convenient, is the range. Remember, that takes 1, 2, or 3 parameters. If there's only one parameter, that would go from 0 up to, but not including 10. So 0 to 9. Okay. If I wanted to go to 1 to 10, I would have to go 1 to 10 plus 1, if that helps you remember, or just to 11. Okay. If you add the third parameter, that's the step, which defaults to 1. That would give me a 1, 3, 5 in this case. Okay, we talked about calculating a running total. Okay, you do that a lot, which means as you go through, you're going to keep adding 1 to it. A sentinel value is just the value that gets you out of something. It's the continue that I used before. Okay, and then let's do an example of a input validation loop. So every time you ask for input, you need to ask yourself if there are reasonable values here. Okay, so let's say I have something like age is equal to int input. Enter the age of whatever we're trying to do. Okay. So age can't be less than 0. It can be 0. Okay. Age can't be, let's say, over 120. Okay, so I need to have an age validation loop. Okay. Those always start with asking. Then we have to determine when there's a problem. Okay. So if age is either less than 0 or age is greater than 120, both of these are an error state. Print out the error message. I have to do a tab, say error, all capital letters. And then we just need to ask for the age. Okay. So that validates or verifies that age is within the appropriate things. Okay. Questions about this? Okay. And then, of course, we can do nested loops if you want. Yes.
Will every program on the test have a error state?
It may. It may not. If I ask you what's your favorite number, maybe your favorite number is negative 21. If so, that's okay. You have to think about the program. Okay? And if you can make a convincing argument, then I'm not going to complain. Okay? If it were me, any input, I would put a comment. This doesn't need validation or whatever. This Just so I know that you're thinking of that. Nested loops, you can have while loops inside of while loops. You can have for loops inside of for loops, whiles inside of fors, and all that stuff. And we've seen some examples of that as well. The time is perfectly good for that. Okay. So, what questions do you have?
Have you figured out where we print the sheet thing here, or do we have to go to the library?
I would have it in my hand before I arrive, to be on the safe side.
I mean, like, can we print it here, or do we have to go to the library?
You can try to print it right now if you want. It should be the room number.
Can we just take your, can we just go back over to go real quick?
That's us, because you want to have to go to the library.
Other questions?
We do need a flash drive for the exam.
Nope. You don't need a flash drive. Necessarily. You probably do. It'll make your life easier. Yeah, that's you're using your life. If you can say to the computers in here, then that's fine. You don't need a flash drive.
I'm gonna assume no music of any kind.
Assume what?
No music of any kind.
No, only that you hear in your head.
Got it.
I have 99 lust balloons tonight.
I will be around.
But it's hard having a language, a foreign language song in your head because you don't really know what they're saying. You kind of make it up. Yes.
Can you go over Boolean variables again? That's the most part.
Okay. A Boolean variable is nothing more. We'll do it over here. It's a variable that holds a true or false, right? So if I say x is equal to true, the type of x is a Boolean. Okay. So the way we use it typically is for one of our sentinel conditions. So again, if I say continue, same example, hopefully it'll make more sense, equal to true. Okay, then I can say while continue, that's all I need to say, while continue. Okay, do something, whatever it is. Print. And then I would ask them again if they want to continue. Okay, so that's where it gets used. The other way we can do it is that we can just make it. I have a variable. So over here, okay, x is equal to 10. Okay, I can say x equals 10 is going to return a true. Okay, so I can say y is equal to x equals 10, which looks weird, but now y is a Boolean variable. Okay, that holds the value of it. Okay, so that's it. Boolean variables hold x and y. That's it. Okay. Yes. Yeah, let me do that. Okay, so let's say, what's an example? Always tough to come up with examples. Well, the one we did in class was students with tests. I guess we can do that one as well. Okay, so if we have, let's say we're not going to ask for simplicity. So we're going to say for students in range 5. So we're going to have 5 students. Okay, so we can print this is working. 0 through 4. Okay, and now we want for each of those. Okay, so we're inside of this loop. I have a for loop here for t in range, let's say 3. Okay, so now if we print t, let's actually print a tab so we know we're inside of this loop. Okay, this is going to do the 0 here. Then it's going to go 0, 1, 2, 1, 0, 1, 2, 2, 0, 1, 2, and so forth. Okay, run this. this is what we get. We're at 0, we do 0, 1, 2, we're at 1. So this is this outer loop. This is a student loop. Okay, so for every one loop of the student loop, we do 3 of the interior loop. Okay. Does that make more sense? Okay. Other questions about this? What else do you want to know?
Can I, like, I use break, but we haven't technically learned that yet. Is that, can I still use that?
Not an exam. I want you to find a way around that. Not a problem on homework.
So we can't use anything we haven't technically learned yet.
Correct.
I just realized on for the homework, I didn't have the nowadays and that's what that's just a
It works.
Or shit.
Yeah, I didn't. Whoops.
I gotta.
No functions.
Ooh. It's so much fun.
It makes you
Yeah,
think.
I mean,
With diminished
All it does is just break just prevents you from having to write just something equal.
Wait, we can't use break?
Yes.
No,
I
no break.
just figured out how to use break and break the pizza.
We'll have break soon. But
Well, I
no
haven't
break
seen
now.
it.
Yeah, I thought about it actually working.
How'd you get it working?
I don't know, I just used it to work out.
What about break and break are still different? They're both sounding like break on the car.
That
Oh,
is
it's
true.
different. I know it's weird. Minute and minute. Spelled the same, but depending on how you say it, you can do different things. Those are the.
They're still the same.
English is
Minute
messed
and
up.
minute?
Yeah, English is very messed up.
Yeah, this is a much more fun English class than English.
I guess the answer is that English is derived from a bunch of languages
Yeah.
and it's just all messed up.
So
People's talk.
another one would be like resume. So that.
And they say that like the word, we have a weird connection between the animal and what we call the meat, right? Pig, pork, cow, beef. And that's because of the Norman invasion of England. That the animals, which were kept by the English people, have the English cow, pig, or English type names or Anglo-Saxon names, where pork and beef and venison, all that are the French versions, because those are the people who were consuming the meat. Class matters, no matter where you are.
Huh.
Just bonus information. It will not be on the test.
Now you gotta put that as a bonus question now. You gotta put that as a bonus question now.
But like, kind of what kind of meaning then to describe what kind of person you are.
Yes, Tom.
We all have the cheat sheet.
Yes.
Continue, functions, we're all on
Yeah,
that.
but we can't use them.
So you can only use what you.
Yep.
Okay.
What if we're not sure?
Yeah, I'll tell you.
So instead of break, I would have to use like, set C equal to true, and then afterwards.
You have to use a Boolean variable. Because Boolean variables are on the exam. But breaks not.
How you go? By the way, when you broke out.
Other questions? Probably just leave it, you can't take it anymore.
See if it works.
Isabel, if you have questions, go ahead.
Hey, wait, no.
Type them in.
I gotta make sure this is possible.
I'll share again if we do something else.
If it does, you're printing your own.
Okay, yeah.
What's that? Okay, like what? In what sense? What do you want me to do? Huh? Okay, exam. What's that?
They play with CI/color.
Okay. Yeah, here's a video of it, but okay guys, let's quiet down. Quiet down. Okay, so let's look at testing if one number is prime, because that does use a Boolean, right? And just to make sure, there's a video, but we'll make sure. So we're gonna pick our number here. We can ask them for it, we can say n is equal to input number. Okay. So the way we're going to do this, I'm going to use this is prime. Okay. I'm going to assume that it's true. Okay. I'm then going to loop through looking for factors If I have one now, it's false. Okay, so it's never going to be set to true again. So I can say while is prime. Nope, that's not what I want. Sorry, I want a 4. We could do something else. Let's say X in range. The range 0 is not going to work. 1's not going to work. It's 1's back to everything. 2 is going to work. We're going to start at 2, and we're going to go up to n. Okay, so if n is 7, we want to check 2, 3, 4, 5, 6. And the range going to n will stop at n minus 1, which is what we want. Okay. So once I'm inside of here, I want to check to see if the number n mod the potential factor x, if that's equal to 0, okay, it means basically that x is a factor of n, okay, which means that is prime is false. Okay. There's no else there, nothing else we need to do. Okay. So I've set is prime to true, and then I'm testing all the possible factors. If I find just one of them to be true, then I'm going to set this is prime equal to false. Okay. So if I run this, something we know, 7, then print it's not a prime. Okay. And since I'm not printing out the whole list, it would make more sense to say here, oh, I'm not printing out anything at all. It doesn't matter. So here I could say, if is prime, it's going to come out of this either true or false. Print that n is prime. Then the only other option is else. Print n is not prime. Okay. So if I enter 11, 11 is prime. If I enter 6, 6 is not prime. Okay. Enter something crazy. That's taking a while. It's taking a long while.
We're probably going to go through every number.
Every number.
Between that and
I'm still
that.
surprised it's taking that long. We'll see if that comes back.
Well, it means, you know,
It's a lot of digits, yeah. Okay, I've killed the computer. Man. But anyway. Does that help? How you use those?
So we kill our program during the test, that's just fine.
Just restart it. It'll be okay. Save often. You'll be fine.
and don't even not control. Don't do that.
And then brings up the movie.
No, it hasn't. Other questions?
Is that what you wanted us to do? Or did you want to go for that?
Oh, I wanted to print out. Yeah, I did something different. Yeah. And there's a video out there that I explain the whole thing. So take a look at it. So the one yesterday would have had an outer loop that went through all the possible numbers from 3 to 1,000. I'm beginning to wonder that something's gone wrong there. It's really weird. It really should be done by now. I'm not sure what could have gone wrong there. Other questions? Sure, if there's any questions over here. Nope, not over there. Okay. The best thing to do for the exam, read through chapter 1 and that first little bit of chapter 3. Make sure you've got those down. Those are easy points, just memorization. Okay. Coming out of high school, you should be good at memorization. What do you do in high school?
Yeah, pretty much.
That's throwing your
What
body.
you just said?
For the rest of it, so for the 2/3 portion of the exam, do program. Just program them. I mean, do ones that weren't assigned in class. Do stuff you can make up with your head, whatever. Okay, so we've got a toolbox here, right? We've got variables we can use. We've got the selective execution. with the ifs, the else, else and else's. We've got repetition, we've got the print statement, we've got the input. That's all we have right now. Okay, so you have to make sure if you're one to be anxious, don't freak out. When you freak out, you can't even read the problem. So find a way to calm yourself down, and then you can go through and get things right. If you need me to explain the problems to you, I mean, always ask a question during the exam. I may not be able to answer your question, but I may. Doesn't hurt to ask. So, if there are no other questions, that's it for today. I'll be around this evening and tomorrow. If you have questions, make sure you let me know.
Really fast.